Yeah, 150.
150. Down. 150. Okay. So yeah, it's a mechanical calculator, and you can do. No. Pardon?
Is it a modern Kurga?
It's no. I don't think there are such things as modern coders. It's like a. I think this was made in '68, or '62 or something. Coders are awesome. So 5 minutes we have for the first one. 5. Splink. Splink. Great. Shall we give people a few more minutes to arrive? Let's actually have a look and see what's on this. Joel, do you care what order we do these in? You want to go first? Do you want us to go first?
You're going first.
Great.
We want the open mic at EA.
Good enough. So, hello everybody. There are still people filing in, so we'll give this another minute and then we'll get started. I'll fill in our name on this. Warren Kumari. What's the date? 201. Yeah, but what's the right German ordering for dates? Year, month, day? Day, month, year? You know, the important things. Put the period in between, right?
Use the ISO order, since that's different anyway.
With a period or with a dash?
What Turkish?
The date format.
Just the date format. What's the right German format for the date?
There are so many. We live in a free country here. You can choose whatever you want.
You can put it all right. Okay, great. Fred.
We will probably even recognize the American data. Because I do it. It's stand up.
I'll go ahead and mount blue sheets.
Thank you. You're welcome.
Alrighty, everybody. So hello and welcome to Ops Area. As is tradition, we start with a note well. Please make sure that you note this well. It has all sorts of important legal stuff. It is important. Please make sure you understand it. We're not going to try and interpret it for you because that's the job of your lawyers and we will probably stuff it up. Blue sheets. Blue sheets are circulating. Please fill them in. If you do not, we won't get a room next time or we won't get the right size room. And welcome to Opsawg. I'm Warren.
I'm Kieran.
We need a JavaScribe and a minutes taker. We need a JavaScribe and a minutes taker.
I can JavaScribe.
Thank you. Who was that? I heard a voice from the back.
Dan.
Oh, Dan. So who's going to do minutes then? We need a JavaScribe and a minutes taker.
Do it.
Thanks, Joel. Okay. We have a full agenda. It takes up 3 slides this time instead of 2 slides. We are going to be fairly strict with time. So if you're speaking, we will try and let you know when you only have a couple of minutes left. When you run out of time, we are going to have to cut off lines and we are going to have to get you to stop speaking. There are many people on the agenda and it's not fair to let people overrun. As I say, 3 pages worth of agenda. Any agenda bashing at this time? Is your name listed here and you weren't expecting this, or the other way around? Okay, Elliot was looking concerned. You're first. Anybody else? Agenda bashing issues? Okay, document requests. The TACACS Plus protocol document, the one that explains how TACACS Plus looks now. The authors have revised this again recently. They believe it is almost ready. So we are going to be starting IETF working group last call soon. There are a couple of comments which they received from Alan recently, and they will be incorporating those, or possibly have already actually finished that. Once those comments are incorporated, we are going to start working group last call, unless anybody has other major concerns to raise. Okay, once again, a reminder, please read the draft. It's actually very readable. It's relatively old because it's largely a copy and paste from an earlier document. Please, let's actually review this and get on with it. And now we will try and find Elliot's document. This is the correct version, right? Do you want the cookie?
Yeah, I guess so. Does it click right?
Should, oh, hang on a second. Helps if I make it bigger. Test the cookie, should click. Great.
Okay. Good morning, everybody. I'm Elliot Lear. I work at Cisco, and I'm here to talk about manufacturer usage descriptions. Okay, so I'm going to spend about 15-20 minutes, hopefully less, hopefully a lot less, talking about what's gone on since the last meeting. At the last meeting, just to remind you, I did a bit of a presentation on what manufacturer usage descriptions are. And so the basic goal of this mechanism is when you have random things that are plugging into your network, you would like to know what they are, and you would like to know how to protect them. And so the goal of manufacturer usage descriptions is to have a way for the devices to communicate what they are, and then for the network to retrieve a description of how to protect them. I've reused nearly every little bit of technology I could get my hands on so that I didn't have to reinvent stuff. And so what they are is pooted out using a URI through various means, and how to protect them is described using a Yang model that is now serialized by JSON. So that's the basic concept, and then you do stuff with the how to protect them that was largely designed in the Paleolithic era when I was a student, called applying an access list. Adrian's looking at me like saying, "You think you're in the Paleolithic? It came from the Paleolithic era." This stuff is trying to do everything that we've pretty much done. There's no data plane changes at this point. So in terms of implementation, it's really simple stuff. In terms of on your router, mostly simple stuff, and maybe not entirely simple, but we now have an implementation, a proof of concept that Brian Weiss and some of the folks with him did. Brian's in the room. So these are some of the things that have happened. So based on comments that we received, we were using XML, but as the NetMod working group has gone through and seemed to approve a JSON serialization, and at least one person jumped up and down and said, "It's 2016, it's 2016, you should use JSON." We serialized in JSON. And so that is a change, and it's a reasonable change considering that on the whole, it's not the routers that are going to be processing the JSON, but some sort of network management system or control. Now, I'd like to also just refer you back to the slides that are in the previous IETF Ops Area Working Group meeting. They show all the flows of communication. The other thing that we had to go do is figure out how to sign the MUD files, these description files that sit off of web servers, and we've done that. We're using PKCS7 or CMS signatures now so that you can validate those signatures. We have simplified the URL just a little bit, and that's in this document. Now, the document itself, just as a reminder, is draft Lear IETF netmod MUD. And so it's called that because we started out in the netmod working group, but actually we started out in 4 working groups. and have consolidated into the ops area working group because there seemed to be interest here. We got good feedback here the last time, and we're hoping for more. And in fact, the documents are consolidated because at least another area director said, well, okay, it's nice that you did the DHCP option. You don't need to be in the DHCP working group to do that. Just consolidate this stuff so that you don't get approvals out of sync, and it's easier for you to work. And so I took that advice to heart, and thus we are here consolidating everything. And that includes the DHCP option, an X-Hub 509 extension, and I want to consolidate one other thing, which is how to do how to handle domain names and access lists, which currently the ACL model doesn't handle, but really should handle. So just what the JSON looks like. This is an eye chart. You go download the slides, or even better yet, this is right out of the draft. You can go look at it, and this is pretty much what you suck down. And if you squint real hard, it just really looks like an access list. And this is how it looks in JSON serialized. And so far as I know, I don't know if we've actually, if we're one of the first people to actually demonstrate the JSON serialization in terms of netmod, and Yang, but here it is. So there's actually a better example of this that isn't. The previous example comes from the lighting community, who are actually interested in this idea. So we go talk to some of the lighting vendors. They're interested. This one actually comes from, there was a paper called Preventing PLC Blaster that was out there. There's a PLC that's out there that somebody actually wrote a worm for. And so actually that was what the paper was here's a worm that can infect PLCs. These are devices that basically do control of various critical functions. And so the guy wrote the paper. And so what I wrote was a mitigation that the network can employ to prevent a worm from spreading using manufacturer usage descriptions. And that's the example that you see here as a case in point. And that sort of demonstrates the value of what we're doing, which is you can deploy this stuff really quickly without actually touching the PLCs, and actually provide some protection of those PLCs, right, themselves. Okay, so we have a couple of big questions that are left over where we need a lot of eyes on, and not just in this working group, but elsewhere. So we chose, did we choose the right approach to signing these files? There are really two approaches that we could have chosen. One is, sort of old, I would say tried and true, but it's mostly true and it's mostly tried. But I think signing on the whole is sort of something that people haven't been doing a lot of, and so we're doing it. And there are two approaches, as I mentioned. One is using JWS out of the Jose working group to sign JSON. The other is to use sort of the trieder and truer, which is PKCS7 or CMS. We chose the latter simply because there seemed to be more tooling for it available, and all we need is something that essentially takes a binary file, or at least something that is treated as binary, which is, say, this JSON file. Just say, take it as a whole, sign it as a whole, validate it as a whole, and people have been doing that forever. Works great, lasts a long time, and unless somebody really wants to object, that's the way we plan to keep it. But this working group could have its input, and the SAG can have their input and say, no, do it the other way. And truth be told, I don't have too much of a horse in that game, in that race, and just people should speak up as to what they want. Then there's a big question that is remaining in the draft, which we really need to look at a little bit more, and that is extensibility. So basically the goal of all of this is to have a relatively ubiquitous deployment. So pretty simple routers like the Frisbees you have at home could do this, and enterprise class routers could do it as well. Which means that you don't want to have a whole lot of extensibility. You have a three-party system. There's no negotiation in the mechanisms at this point. So you have to have declarative forms of extensibility. So we started out. I started looking at this, and I came up with a really convoluted approach that uses manifests, and you match capabilities to you would match capabilities to particular files, and then retrieve those files. And it was really ugly. And Cullen came to me and said, Elliot, this is really ugly. And I had to look at it and said, you know what, I agree, this is really ugly, we need a different approach. And so the next approach we ran with and have been running with is just a very simple version in the URI. And that works great. It's relatively stable, but it's very coarse. And so if people want to add lots of additions, the coarseness of that might get in their way. And so the next approach that I'm pondering and can use more eyes on, and extensibility is an area where we really do need more eyes on, is the idea of saying, okay, let's find a way to deal with with extensibility such that you have sort of a critical versus non-critical. And when you allow non-critical stuff in, that is to say, things that won't break if you don't understand them. Okay, if you don't understand it, you can ignore it. You allow that stuff into a file, and for stuff that would break things, you say, okay, we bump the version and we do another version of this. Now, this is a relatively new concept. It involves the manufacturer taking a more active role. So we expect over time that when we get more operational experience, the manufacturers get more operational experience, they're going to want to do some additional stuff. So we do expect to do at least one more version. So we'd like to get it close to right on extensibility. It doesn't have to be perfectly right, but we'd like to get it close to right. What's more important is that we get some operational experience and that we get more people involved and actually have a couple more implementations. But I would like some more eyes on this, if you would. So then we have a couple of other ideas that have been cropping up. I was talking to Torsten over there last night. We were talking about how do you handle the reputation of a manufacturer. So some guy brings in a device into your system and into your network. They plug it in, and it wants to retrieve a file from a place that maybe has not your best interests at heart. How might you protect the MUD controller in this context from being attacked? And so we have some ideas about reputation, which leads to a broader issue, which is the security considerations, of course, on all of this stuff needs to be reviewed, and we need more eyes on that. So this is something that we're thinking about. Now, Paul Hoffman has previously done work at the IETF on attestation. There's been other people who have done work on attestation, and maybe we should just use an attestation model that helps or allow for an attestation model in the Yang model so that you can at least see, well, yeah, I, Cisco, have looked this file over. I think it's okay. I think it's going to be safe. And, that way you could trust it. Or, such and such attestation authority has looked at this and therefore it's safe and maybe you trust them. And so that model needs to be looked at. There's nothing in the document about it today, but I'd like to think about that. So there's one remaining thing to be dealt with that I want to deal with, which is there's the separate draft out there, draft clear IETF netmod ACL DNS name, which does the extension for the ACL to handle domain names, for the ACL model to handle domain names, and I propose to just incorporate that. So that's the whole thing in a nutshell. And so I have a request. And my request is I'd really like to see the Ops area working group adopt this work. And I'm seeking comments on that idea. I'm seeking comments on the idea as a whole, and I hope you have some. And I hope I've given you, I've done this in a reasonable amount of time.
Yeah, we still have a number of minutes for questions, discussion, and especially feedback on is this good for Opsawg? Should we adopt it?
Dan Ramashkanu, so I'm pretty supportive on the idea and the whole concept, but kind of clarification question to the request. This work actually, what actually are you asking to be adopted in the Ops area work?
What I'd like to be adopted, so there are actually 3 drafts, but I only really care about one. And the one is draft IETF, draft LEAR IETF netmod MUD. But I also propose to incorporate the DNS name model into that as well, as a separate model, but as part of the document.
So actually what you are saying is that you are continuing the process of consolidation by,
yes,
and actually that's, so it's one more iteration and then the result of that iteration is
yeah, but
what you're asking to
if it's okay, Dan, what I'm just saying is, if this group likes it, what I'll just do is do that and then publish it. I would publish it as a -00 if the group decides to adopt.
Yeah, that's fine.
Hi, this is Henk Burkos from Ronald Fraunhofer's. And first of all, I love this also. It's there to help. It's there to provide guidance in some way that typically is not available at all. And it's easy to use. So thank you. That's a very good approach. And you had one of your slides, you had the AR identifier listed, and that could include a pointer. And we were pondering for a month now how to squeeze some self-descriptive information into that AR identifier without making it way too complicated and again useless by that. And so because we have to deal with devices that probably have a zoo of dev IDs because they are composites and modular and change over time. And automation basically is kind of particularly with that. So we want to do some guidance also at that point that if you have this FID, if you have to include this pointer, maybe, I don't know if this is an appropriate place here, but maybe we could have some indications what this implies to other dev IDs, like a self-descriptive features regarding composite devices. This is a very specific use case we have in mind here, and you have I think a linear but a parallel use case here. But if you would consider this, and if there might be a way to somehow use the same pattern and maybe another model, that could be an interesting way to do this, actually, and not squeeze it all in, but use the existing factors that are in AR. And also, we were talking about extensibility, and typically, I wouldn't say this, but you're using JSON, and the CBOR representation, which is basically one-to-one to JSON, has a very distinct own description language, and this is easy to go extensibility.
Okay, so let's see here. In order.
Yeah.
And thank you for your time yesterday, by the way, when we sat down, we stood up and talked at the counter. One of the nice things about this model, so one of the constraints we have, right, is that some of the things that are going to be using this model are really small, and the only thing they have to do is just put out the URI, right? The manufacturers don't have to spend a lot of cogs in processing anything other than just putting out a URI somehow. But once the network gets a hold of that URI and retrieves this file, right, what we can do is take some time in this working group and decide, using that method of redirection, you can retrieve, not only can you retrieve that file, you can point to other things in that file. So one of the other changes I didn't mention, but it's in there, is that there's a pointer to the MASA server, which is the work of the Anima group. Right. So the idea is, if you use this file, for instance, you can locate the MASA server of to do key bootstrapping as you will, and you could do something similar if you want to be more expressive about capabilities of the device that are unrelated to, say, access lists. Mm-hmm. You just have an optional pointer that points off in that direction. And we do have this meta information area for that, and that is what I would say a perfect example of non-critical. That is to say, even if we extend it later in a non-critical way, right, whether we do it inside this model or later, it's something that it's very safe to do, mm-hmm. right? And so I think there's a lot of room for different ways to meet your desire, mm-hmm. as long as we have an understanding of what your desire is in terms of the model. So I think you have to write I think you need to write a little bit of a draft there. Now, as to CBOR, right, the encoding, whether it's JSON or CBOR, remember the serialization is coming from a Yang model.
Yeah, I see.
And so the Yang model specifies.
The sensitivity problem is not on that domain, but coming from Yang, actually. Yeah, okay. Right. That's your problem. I'm sorry to hear that. But,
yeah. Okay, so I mean, I'm very happy that it's there, right? Because it meant I had to do a lot less work. And I'm very, very indebted to the Yang community for that, right? I'm a user of this stuff. I'm not a developer of Yang, which is, I go to the NetMod working group, and those guys are working really intensely. I'm really happy to be using their work and not having to develop it.
Okay, thanks.
Other comments, questions? Do people like the idea? Do people hate the idea? Are they bored by the idea?
So actually, I guess let's do a quick hum. This isn't going to be actually, are we going to adopt this or not, because we haven't seen the final document, but instead be a hum. Do people like the idea and think that we're likely to adopt, assuming it seems sane when it comes out, or do people not like this and think that it doesn't fit here? I think last time we heard fairly strongly that it does fit here, but worth getting more feedback. So if you think that this seems like a good idea and probably stuff that Opsawg is going to want to work on, Please hum now. Great. If you think that this seems like a bad idea and that Opsawg WG shouldn't touch it, please hum now. Great.
Oh, one more point.
Sure.
Sure.
We run.
Sorry.
No. It was not a blank check.
No. Just, I was just going to mention that I know that Torsten and Steve over there are also, they're doing a draft on looking at life cycle management of this. So there's going to be other drafts coming out, but I'm just talking about this draft, but coming attractions.
Great. Thank you.
So what do you take from that hum, by the way?
Oh, sorry. Yeah. Joel, I think you're taking minutes. There was strong support for we're likely to adopt this. Once we have the new version of the document, we'll share it and then very likely adopt it. Okay, next we have...
Excuse me. Sorry for waking up so late. I should have done this during agenda bashing. If I look at the next two topics, I thought maybe it's better to have them switched so that we...
Service models explained, then requirements of composed?
Sure. Because they said that requirements of composed is a service model, right? So if we maybe get a better common understanding, then
happy to do that.
Well, I would also hate to the presenters now all of a sudden have to.
Yes. So speaking for the next presenter, I'm okay to speak.
Excellent. Thank you. So in that case, we will be doing service models explained. Actually, I think that one. Oh, but you need the clicky. Elliot, did you steal the clicky?
No, it's sitting right on the desk.
Oh, hidden behind me there. That's okay. I'll blame you anyway. Everyone always does. So you have, oh, this is just 5 minutes apparently.
Okay. Test. Okay. Good morning, everyone. My name is Qing. I'm here to discuss this service model. This service model actually was defined in the IETF and it's covered by the LCSM working group.
Can you get a bit closer to the mic or move it up?
And this is 0.1 version of Java. We actually, based on discussion, we give an update, and the author we list here. And next. So why we are here actually? Service model actually in the IETF we actually a large number of models are proposed in the IETF, and most of the models actually use to model the device and technology protocol, but very few models use to model the service. So we actually get keep being asked what is the service model is, how the service model is different from the device model. And so we like to use this chance to discuss a little bit about the purpose and the scope of this service model we define in the IETF, especially that model we cover in the FCSM. Also, the service model actually is consumed by the orchestrator, and the orchestrator is actually it's part of the SDN architecture. So we also want to discuss how this service model is positioned in this extended SDN architecture. And I think many people have some misconception on the service model, so we also want to cover this in this topics. So this is the terminology we use in our draft. Hope everybody can on the same page for this. And here we want to highlight the two important terminology is network operator and consumer. These actually are two terms. Actually, the relationship between them is one actually is own and provide the network connected service. The other one is the one to consume to purchase this connected service. For the service model and the data model, the data model actually is well defined in the RFC 3444. And in this RFC, we also clarify the difference between the information model and data model. For data model, actually, they more focus on to model the managed object in lower level abstract. They describe some details on the managed object. So service model we discuss here actually is a specific data model. And so what is the service model? How we use this kind of service model? In LCSM, we actually define this kind of service model for L3 VPN service. And this model is used in the interface between the customer and the provider. And it will describe the service requirements, service characteristics, and they will use the communication protocol like RESTconf, NetConf, or maybe RESTful API to communicate this kind of service model with the network provider. Also, for supported encoding format like XML, JSON, also we can support some human readable format or machine readable format.
Yeah.
Question?
Mehmet as Nokia, can you go one slide back?
And just to note, there's only about 2 minutes.
At the beginning of the presentation or of the discussion, I just would like to suggest to narrow down the focus. Especially, I disagree with the term service here, with the definition of the term service. Mm-hmm. And I mean, service is a non-term, like security or network or God. You need to narrow down the focus. What kind of service are we looking at? And then we can understand better.
Great, good comments. Yeah, we can actually fix in the next version. And this service model parameter will be consumed by the network operator. They actually will translate it into orchestrator configuration parameter. The service model will not code implement on the network element. Actually, this is a network operator. They use some network manager to actually try to populate this configuration parameter on the network element. So here, so what's the position of the service model in the SDN architecture? So we give two architectures. In the left, actually, is traditional SDN architecture. We have the orchestrator to instruct the SDN controller, and he have a wide overview of the networker. And the controller actually, they program the network element. They will configure the network element. Also, they can get the monitor information from the network element. So now we have a service model introduced. So service model is actually sit on top of the orchestrator. Actually, we have customer getting engaged, and the customer actually don't care what technology is used. So they we here we split the orchestrator into.
And you're gonna have to speed it up a bunch. As it is, you're at 5 minutes. So faster.
We split into service orchestrator and network orchestrator. Service orchestrator more focused on actually network agnostic parameter, but the network orchestrator more focused on the network aware parameter. So for the interface between the service orchestrator and the network orchestrator, actually, this kind of interface has already covered, taken care by the BESS working group and RTGW group. They deal with some network instance model and network centric model. So also we want to mention actually there are several RFC actually mentions they split the control component and expose the service interface so we want to clarify some misconception. So what a service is actually, service in the service model is not a infrastructure as a service, software as a service, or platform as a service. Service here is actually kind of connected service or internet service. So we want to narrow down the scope to more focus on that. And for actually service model don't take care of the network operation. They don't expose more detail on the technology or the resources used to deliver a service. One example actually is point-to-point virtual link service. This can be provided by some tunnel, network tunnel or streetwise tunnel. We cover the point-to-point virtual link.
You've got 30 seconds, then I'm going to have to cut you off.
Oh, okay. So we also actually want to mention the SLA is another issue. SLA actually has the high degree overlapping with the service we define the service model. They also include some commercial term. We don't want to cover more detail on the SLA, but we did cover some basic parameter like bandwidth. So we think this SLA parameter can be augmented from the standard service model. So for another two slides discuss what kind of parameter should be included, what kind of parameter should not be included. I don't want to waste time for this working group because I just request 5 minutes. So if you are interested, you can make comments on the list. We can take offline. Thank you.
Thank you.
Sure. Benoit Claes. So I agree this is a very important topic. I've been spending way too much time in my life trying to explain that with different audiences. Now, we've got a working group document in NetMod, which is about classification of YANG modules. And one of the objectives there was to distinguish between service model and network element model, specifically in discussion with different SDOs where the keyword service is different. So that's there is some overlap there, but that's an important topic, yes.
Yeah, we did discuss this with author about this.
Very quickly, very quickly.
Okay, so because you are talking about service, actually, I think everyone is talking about service in the industry. So this draft is trying to define the scope of service within OPS or within IETF. So what is the intention of this draft?
Intention draft, actually, as I mentioned earlier, actually, we as a SM working group chat, we are keep being asked what a service model is, how this service model defined in IETF is different from the device model defined in mostly covered by the routing area. So we try to clarify this in this draft. I think, as Bama mentioned, actually, there's another draft is about the classification. Actually, we actually serve different purposes. We didn't have some overlap, but we try to clarify what the service model we define the IETF is doing and try to make a distinction with some worker developed in some other SDO or some other area.
So this draft is actually trying to define the scope of service work in IETF.
Yes,
that's the intention.
Yes.
Okay.
Thank you.
Sorry, Adrian Farrell, as a co-author. No, it's not trying to define the scope of service in the IETF. It's trying to define the scope of service model.
Yes.
Okay. Okay. Thank you very much, and great. And thank you for being willing to swap. You have 10 minutes, or when you've got 3 left. Do you want to click it? Or I can click, whatever you like. Right.
Okay, so yeah, so thanks for Wuxin's presentation. I think that is useful for my presentation because he gives the definition about the interface. I mean, service orchestrator and also the network. I mean, the network orchestrator. So I came from mostly open source part. I think we defined that as a resource orchestrator other than network orchestrator because resources cover more. So, so first of all, what I'm talking here, and as I think Wuxin has presented before, is about layer 3 SM is more like customer facing interface. And here I'm talking about is like an operator interfacing interface. So that is about, he mentioned about the difference between northbound interface and also southbound interface, because the user doesn't care about what exactly in the operator's network infrastructure. And we as operator, we need to figure out that. So that's the major motivation. But to be honestly, so each segment, each domain for the operator infrastructure, I mean, each controller has his own data modeling of the services. And we are here, today I'm talking about the composite, or two domain or multiple domain. That means composite service modeling. One of the reference I can bring here is came from the MEF. They are talking about, you can look at the red color, they are talking about the business application and also like BSS or application. Then southbound to the OSS, I mean the resource orchestrator, then we have some interface between them. So here I'm mostly talking about that part of why we need a composite, because we need cross multiple domains. The use case is here we are talking about is like we have multiple that means multiple domains services. For example, you have the optical, you have the IP, you have different transport protocol, transport domains. Then you need composite all of multiple domains into one service. So that's the very important for the operator. We are deploying today individually, independently domain, I mean for the network services. But today is different. SDN is expanding, right? NFV is expanding. So what do we need to consider? We need to consider multiple cross-domain services. So that's the motivation. I mean here. So we try to compose layer 2 and layer 3 VPN cross multiple domains. And also this gives us one of flexibility is when we add one more site for the enterprise. If, for example, in Germany or in China or even in the United States, that could be easily added into the end-to-end service for the composite service for the enterprise. So this is a motivation use case here. So one example you can see is this is the most simplest one. Almost all enterprises like this because they have both access side. So speaking for the operator, we have the like transport-based layer 2 VPN for the access side, but we have the IP-based another controller for the layer 3 VPN side. But for the enterprise, we need to provide them the end-to-end services across multiple domains. Then we need composite the network service. This is the first example I mentioned here. Data center could be either public data center or the operator data center. The other use case I can mention here is also like we have multiple sites. So different sites have different connections. I mean access connections. This could be the transport or it could be the IP access, anything. But they have different controllers at different layer 2 or even in the core side, they have layer 3 VPN. So that service is cross domain. As I can see, based on our deployment experience, so we try to expanding the SDN coverage in our network. Let me try to abstract them here by the diagram layers. So you can see the element on the bottom side. And also we have segmented VPN. Either that could be segmented, I mean here, it could be only one domain. So like, for example, only access or only core side. So this segmented VPN need to be connected by the composite VPN on the top. So then we have the resource pool and resource pooling in the operator side. That's have the access point list information and try to, based on our resource repository, we can connect all of the connections among the different sides, among different, I mean the access or core side. So that's the very important for today because today we are deploying the segmented services for the operator deploys SDN. But I think time is shifting. I mean, we are trying to move forward by connect them by composite services. So that's the motivation here. So we can try to briefly discuss here. You can see the composite VPN could have the basic information which cross the multiple domains topology. And we can also, we need to define the access point list. That is the most important because operator has a repository of the resources everywhere. Those information is helping to connect cross domains. And then you have the bottom side, you can see how we have a segmented VPN list that is a describe of each domain information within the each domain. So that is basically how we design these. Yeah, please, questions or comments.
So my name is Michael Shaw from Nokia. A question on that slide here. Should I understand this as a proposal for a Yang module?
Yeah.
So why in the Yang module you actually need both the overall composite service and the segments? Why does this have to be in one Yang module?
So it's one segmented is Yang defined the segmented service like the layer 2 VPN or layer 3 VPN. But when you go connect to multiple Yang modeling for the different layer 3, layer 2 VPN, then you comes out the composite part. I mean, that's the we described.
Yeah, sure.
Yeah.
I mean, the use case, I strongly agree. The use case is
okay,
very
thank
valid,
you.
but the question is why there has to be in one model the end-to-end composite service and the segments.
One end-to-end and the segment.
But why in one model? So what's the use case for having everything in one model? That's the question.
Okay.
In one mode.
That's good.
Yeah.
Module. Yeah.
So,
and 2.5 minutes left.
Yeah.
Including Q&A.
Yeah, sorry.
Oh, that's strict. Okay. So thank you. I can write back you to the list. So I think we still allow the independent segmented part, but we are composite is mostly, the composite part only. Yeah, go ahead.
And a clarifying question. When you talk about segments, is that across multiple operator or is it all within the domain of one operator, maybe multiple domains, but all operated by the same operator? Or are you talking about VPNs that maybe in Europe I connect to Deutsche Telekom, and maybe in China I connect to China Mobile, but my international company wants to have a VPN between those two, right? Is that what you're talking about? Is that what the segments are, or is it all within one operator?
So segment doesn't mean you necessarily cross the multiple operators. Segment means you have the like a layer 2 VPN only as the access side, or so all of segmented could be within one operators. So the question mostly
could be or have to be.
That's related to security, like trusting that many serious consideration for cross operators. I mean, we are not yet that stable yet. I think it's to deploy SDN, you need to firstly segment domain first, compose the second, roaming third. So I haven't talked about the roaming part. I mean,
right, but you know, if it has to be between multiple operators, then having a standardized model and everything is much more important.
All right.
Than when it's within one operator, right? That's why I have the question.
Yeah, I think this could be used for the cross the operators, but we need other more like security or trusting information for the global connection.
So you haven't really looked at that piece yet.
Yeah, once finish this part, we can go that way, take that part.
Dan Bogdanovic. So I'll ask you, how many operators are participating in your draft? That would be number one. And for APIs between the operators, do you know what KPIs and what information they are willing to exchange? Because it's one thing to set up an L2 VPN as a service inside, and pushing it down to the devices. And there's a completely different set of rules when the operators are what they're exposing to their customers and what they're exposing to other operators. And I haven't seen anything what is important to the operator level, for their business parts and exchanging information. You were solely focusing on the protocols, and I don't think this will fly with the service providers.
Right. So the two questions. The first question is, so I'm here today because I'm not saying we are really so brave to do something early at stage deployment, but I'm here is to show our experience speaking as one operator. So we try to invite more operators. If you are the prediction of your future deployment, then come to join us. I'm happy to work with you.
I'm not an operator, I'm a vendor. So, but I'm from a vendor perspective, I can understand this, but knowing, the service provider part, I'm not sure that, I can map what you're having here to what the service providers are doing. Just my comment.
Right. So
you're going to keep them really short, your comment.
Well, so my question would be, are there any other operators here that have an opinion? I mean, I'm not an operator either. Dan is not an operator. So, we can talk about this. We have one operator presenting, but if there are others, I'd like to hear their opinion on this material, right?
Yep, and actually, I guess we'll hear that on list. So if there are other operators, please send your comments on list, or just stick up your hand if you think this is great. Seeing as it's called Opsawg, that's sad.
Yeah, I can talk with all of them offline. Okay.
Benoit Claes, just one observation.
No, just to make there was a comment behind me that about me being shy, which is I can be accused of many things, but not of being shy at all. So, no, frankly, this is the first. I have not read the draft, so I cannot. I don't have a strong opinion so far. Oh well, this composition system based on LSO is something that we are. In my unit, I mean, in my team, we are looking at it with a little bit of skepticism. Only that, and that doesn't imply that we are not or we are interested in it. But just so you were asking for operators, here is an operator. We are looking at it. We are not 100% happy.
Okay.
With the general idea. I mean, not with this particular proposal.
Okay.
But who knows?
Great.
So well, we can talk about this later on, but just because people were asking, just here is an operator, and basically, I don't know.
Right.
So, Benoit Claes, very short. We need to make a distinction between the general concept of service composite.
We're cutting the lines.
So we need to make a distinction between the general concept of service composition that is required within an operator, across operators, etc., and your specific use case, right?
Yes.
This one needs to be solved and is being solved because that's what you need in any orchestrator. And by the way, we did the schema mount in NetMod to answer the first question from the gentleman there, to be able to link part of Yang models into a service.
Mm-hmm.
And sorry, we've cut the lines off.
Yeah, right.
Just for.
Okay, thank you. So we really would like to welcome if you are, because not every operator is at that stage, but we need to welcome the operator you are in that stage to work with us. Thank you.
Great. Thank you. And Dan, we have next, and 5 minutes with questions.
Hello, I'm Dan Romascano, and that's an update on the auto-attachment work that you first presented in Buenos Aires. So the concept, just to remind very quickly about the concept, it's the concept of configuring a network actually from the edge and allowing for the attachment of the end station to the end device and for an exchange of one-hop exchange of information between the end station and the network device. It includes two phases, a discovery phase and the configuration phase. And the configuration actually tries to avoid the overload of configuration of end station in very large operations. Next slide. Actually, can you skip 2 slides, please? That's a bug in my presentation. So that's how the current concept looks in our internet draft. So we have a controller basically configuring the basic information on the network device, and that's mostly policy information. In some cases, and we'll detail because that was one of the comments, we make configure also the end station on some basic information. And the attaching primitives which run the discovery phase and then they run the configuration phase. Can we get back to slide 3? Okay. No. Okay, slide 3. Okay, so what have we done from since IETF 95? One of the comments was the internet draft was kind of a mix of information about the framework, which is generic, and the layer 2 implementation, which is the first thing that we have done, and done written and deployed code. And there is an open source project also running. So we split that. So we have now a framework ID, and we have an implementation ID that kind of details the implementation, which is based on 802.1ab LLDP. Some clarification of the terminology. The functional description, so we went into more details about describing the discovery process and describing the configuration. The LLDP draft aligns with the evolution of the 802.1 QCJ, which is the auto attachment layer 2 protocol running as a project that is being run in the IEEE. And we also included as another option, we included the possibility of using the discovery phase, actually a MUD exchange, which basically MUD fits here also very well the type of functionality, identification and basic authentication of the device connectivity into the network with reference to the manufacturer information. So we believe that fits a lot as well, and if interesting, may be developed in further work. Now skipping another 2 slides ahead. Okay, we got a few comments, some of them offline. I will discuss those that we received online. A couple of comments basically were referring to the fact that it was not clear why both the controller, the server, the controller needs to interact both with the server and the client. So the basic concept is actually to simplify configuration, and in these cases, in most of the scenarios, the interaction which we define both as horizontal interaction, actually should fit in the bill and allow for a configuration only on the server side. And this is true in many of the deployments. This is true especially in the IoT environment. So the idea is indeed that the edge devices will carry the policies, as this is where the young models that we are planning to develop basically pushes the policies into the end devices, while after the discovery process is being performed, the configuration process is allowing to exchange the information about the services that is being run on the edge and going into the device, and the mapping process happens in the server which runs in the network device. There is, however, at least one use case where you may come, for example, with your own device. Is a famous bring your own device concept, where actually you need a level of configuration of the client in order to make aware what services are being run in the client and how they are identified. So this is why the diagram actually keeps also an option for configuration of the edge device. And that's actually was kind of answering to for both items, because indeed the second observation was that there can be a simplification of the interaction if both edges are being configured by the controller. This also avoids the concept of the controller, and all the controller logic is out of the scope, at least for the current phase of the work. Basically, the domain where the network device resides in is different usually from an admin point of view than the domain of the edge devices. And this is one more reason to focus the configuration on the device on the network. Another comment was about using another possible use case, and that's the cloud VPN, actually allowing for a private cloud to connect to the network and to using auto-attach for identifying the functionality or the services in the VPN cloud. That's quite an interesting option. It looks like it's something that that can be incorporated as a use case. We need to explore it because at this point in time, at least the data model that we have is directed into physical endpoints and not into virtual endpoints. So we need to understand what more information is being brought by the VPN cloud case. Next one. So the change, so this is a clarification that we'd like to bring following those discussions. So kind of showing that more clearly that the controller logic is at this point out of scope, and if there are like two domains and some kind of what some people call orchestration function between the two, this is not something that we would like to develop here and clarifying the auto-attach scope. Next one. And last meaningful one. So the status of the project right now, we do have a running and deployed implementation. It is based on LLDP extensions. The LLDP extensions are standardized in project in IEEE 802.1 QCJ. There is open source that is available. With the next steps are defining the young model for the policies. That will be a separate piece of work. We would like to look at the option of MUD and see whether maybe we'll kind of need to speak with Elliot about it, but we may insert maybe as a use case in the future MUD document, or create an informational MUD extension. I less prefer, I'm lazy, I like short sections in other people's documents. I don't believe that we had enough discussions or feedback. We had some positive feedback and some queries, but probably not enough discussion to ask for at this point in time for adoption in Opsawg working group. But we'd like to hear feedback and consider this for the future.
Great. Comments and questions? Feedback? And while Elliot's getting up, you say open source code available in ODL.
Yeah.
Sometime can you send a link to that to the list so people can find
I think so. Paul.
So the open source code is actually not only in ODL, it's also in OVS, and that could be found up on GitHub. So we can send out a link later.
Great.
Elliot Lear. I think this is good work, and in terms of including an additional paragraph or so or whatever, let's see what you have. And I don't see any objection, but I'd like the group here to have their say, because I really do want to.
It's more like 3-4 paragraphs, right to speak.
Yeah. I mean, I don't see any particular problem with it, but just need to see it. And I do like this work. I'd like it to continue and continue to develop.
Okay.
Laurent Chaval, Nokia. I think you're aware about the Anima working group work. There is a secure bootstrap activity going on. How do you see these two relating? Because it's also attaching new devices to a network with a security process. So
right. So this goes a little bit more than the bootstrap, because of the mapping logic that happens in the network device. So there is a bootstrap process indeed but basically the edit value is into mapping the service into whatever tagging or routing header you put in order to execute the service in the core.
Okay, but would you see that the, for instance, secure bootstrap work could be integrated in as
yes.
a first step? Okay.
This is Elliot again. Somewhere along the way, I actually did up a table that looked at there are a bunch of different sorts of proposals, and then I actually did up a table. What I'll do is I'll send that off to the Opsawg WG, but I want Dan and a couple of people who actually are listed in the table to say, yeah, that's right, to make sure I understand what's going on. But I'll send that off.
Okay, thank you.
Great. Okay, excellent. Thank you very much, Dan. And you have 10 minutes for this. I'll let you know when you're getting down to like 3.
Hi, morning. My name is Gu Rong from China Mobile, and I'm here to share with you the draft about exporting BGP community information in IPFix. And my co-author is Zhenqiang Li and Jamie Dong. The draft is about the IPFix. As the IPFix work group has been concluded, so I submit the draft here, and thank you for the precious time. About the background. In traffic engineering, traffic load balancing, and traffic steering, network administrators need to get the flow information with amount and direction of traffic in their network in order to make the network optimization. And thus, the IPFix is designed for exporting the formatted IP flow information. Up to now, the flow information is transferred from an exporter to a collector with the information elements defined, such as the source IPv4 address, destination IPv4 address, source transport port, destination transport port, BGP source AS number, and BGP destination AS number, and many others. However, in some circumstances, we think that the BGP flow, the BGP community-based flow information need to be exported. For example, for the traffic engineering in operators backbone network, flow information based on the existing information elements is not always suitable. On one side, the flow information based on the IP address or IP prefix is meticulous, as there are many IP address and subnets in the backbone network. And on the other hand, the flow information based on the AS numbers is too coarse. So we think that the BGP community, which describes a group of roads sharing some common properties, can provide the suitable flow granularity. Thus, we think that the flow information based on the BGP community needs to be exported using IPFix. However, up to now, no existing information element is defined for the BGP community information. About the flow information based on the BGP community, we come up with two architectures. One is with the mediator and another is without the mediator. In the first architecture, including the exporter, mediator, and the collector, the exporter does the job by collecting the information based on the existing information elements, while the mediator does the job with new information elements for the BGP community by collecting the BGP, by correlating the BGP community with the flow information. And then the collector does the job for collecting the flow information based on the BGP community. This is the first architecture. And the second architecture, the exporter connects with the collector directly. Thus, the exporter exports the flow information based on the information BGP community by the new information elements for BGP community. And that's about the information elements definition. We recommend two kinds of information elements here. One is the BGP source community list, and another is the BGP destination community list. Both the IP version 4, IP version 6 traffic are applicable. And from the previous architecture, we can see both the exporter and the mediator can use these two information elements to export the information we need. And about the details of the information elements, the first is the BGP source community list, which describes the BGP community information corresponding with the source IP address. Its data time is basic list, and its data time semantics is list. We do not need the unit here. And about the BGP destination community list, which describes the BGP community information corresponding with the destination IP address. Its data time is also basic list, and its data time semantics is list, and we do not need the unit either. So the next step, we recommend two kinds of information elements in order to export the flow information based on the BGP community. And we want to see if any other operators or also operators have these similar requirements. And any comments and contributions are welcome to improve this draft. And maybe later we ask for group adoption. Any comments? Thank you.
Benoit Claes. So a couple of comments.
Okay.
First of all, I was just looking up the IPFix registry.
Okay.
And it's expert review. So basically, you can just go and request it, and it will be expert reviewed.
Okay.
So that's one thing. Second thing is, yes, this BGP community is important. The third point, which is this would be the first information element based on the lists.
Okay.
We actually open maybe the Pandora box by having lists in IPFix for this case. There might be some other bad cases, but okay, so maybe that might be one situation where we clearly explain how it's done because it's the first one on a basic list, or a list anyway.
Okay.
So of two minds here, going directly to the experts or documenting it because it's a special one.
Okay, thank you.
So I have a quick question.
Okay.
This is mainly for the group. To me, this sounds like a useful thing. However, I wasn't involved in the IPFix working group. How many people do we have here who were involved in some way in IPFix and so are capable of reviewing Okay, I think it would be useful if we can get some more people who were involved in IP fix work to, know about this and come along and help review. Also, a very quick hum. I'm assuming that a lot of people have not read the draft, but for those who have, and also just based upon the presentation, how many think this is a good idea? So we'll have 2 hums. Do you think this seems like a good idea and worth working on more? And then another one of, no, this doesn't seem like something that Opsawg might be interested in. So and that's purely just a general idea thing. Yeah.
Right, but do you support this? I mean, you could directly go and request it now if you want, right, in registry. So your question is about explaining in a draft and working on this here, or not?
No, I think it's more, is this something that Opsawg thinks is interesting to work on? And then the other one is no, Opsawg does not think this is interesting to work on. You can just go request it as a separate thing. I think it would be interesting for the document better. So first hum, do you think that this is something that Opsawg is interested in working on? Hum if yes. If you think that Opsawg is not interested in working on this, hum now. Great.
Thank you very much.
Thank you.
Thank you.
And also thank you for fitting in the time nicely. Thank you. Okay, and I believe that we now have our last draft, which is in-band OAM, or not draft topic. I just need to find it. And you have, yep, I found it, and you have 15 minutes. Do you want the clicker, or you can click with the clicker? I'll let you know when you've got like 3 minutes.
Hey, good morning. We're going to go briefly chat about in-band OEM. That's work between a couple of us. All of us are listed on the draft. So a quick one on nomenclature and terminology, because, well, it's a little difficult finding the right term for what we're doing. And I compared that to how you kind of operate on the road and the street. So you can either do probe-based, like the police is going to go shoot your speed, or you can do what the Germans do, which is an onboard unit, which records what you do in all day, all times. The one concept allows you to understand what happens at a certain point in time using some probe information, and you might modify the system by sending the probe. The second one is, again, you modify the system slightly because you put another unit into the, well, truck or lorry, depends on where you're coming from, and then monitor the behavior at all times. And again, you might change the behavior of the truck driver by having that unit on board, but still you understand what the truck is doing at all times. We are focusing on the onboard unit, so the in-band OEM, where we are adding information to the existing packets, i.e. all user traffic, as opposed to sending probe traffic, which is what you do with ping, traceroute, Ethernet, CFM, and the likes. So a couple of motivations. So how many people ever went to SpeedNet or speedtest.net? Probably all of us, right? And if you kind of look at the rumble in the internet, many people moan that this test goes really well and their connection is slow. Maybe there is an indication that certain people prioritize certain traffic, especially if it's probe traffic. Yeah, I can do that so that the SpeedNet or speed test looks nice and other things don't look so nice. And I even heard people kind of saying, well, that the round trip time between Asia and the US is something like 30 milliseconds. That's a little bit more than the speed of light. Happens. So it would be useful to have the information that you want to go measure, or the capability of the measurement within the data stream of the customer traffic, as opposed to you sending extra traffic that might get special treatment. So that's one use case. Another one is, well, if you send probe information, which path do you send the probe information on? In certain cases, yeah, you can send it on all paths, but in certain cases, especially with IP and traceroute and ping, they are on one path, and you might be interested in other paths. So ECMP and tracing ECMP, we have that forever. Another use case is you want to go make sure that all traffic traverses a specific path. So you want to verify that traffic makes it through a specific path. If you want to verify all the traffic, all the packets, you've got to verify all the packets. So you better put the proof into the packet as opposed to you're observing the system
because, well, if you're observing at a certain point in time typically. And there's all kinds of other things like customer level telemetry that you can think of. You can put GPS geolocation into the packets and understand where packets, certain packets are going and implement policy on that. So there's a couple of use cases that might help us. And well, if we put metadata into the packets about where the packet's traveling, at one point in time it visited a particular node, whether it really visited that node, with some cryptographic information to the packet, that help us. So I'm trying to make the case here for putting more information, more metadata into the live data traffic for all the live data traffic eventually. And going through the use cases that I just mentioned, so end of the day, if you do the analysis, it would be useful to record things like node ID, ingress interface, egress interface, something that proves the transit, so some cryptographic piece of information, and we talked about that yesterday in both the SFC working group as well as in Spring. Sequence numbers eventually in order to find out whether traffic was dropped or not. If you have a protocol that doesn't support sequence numbering, timestamping what traffic happened to be at what point in time at what particular node, and maybe even custom metadata, and I mentioned GPS geolocation information, for instance. So yeah, well, I think that's the idea. And now you got to go find a home for where you put the information into the packet. So we have to go and agree on two things. We have to agree on the format, and better we agree on one format, no matter what the transport is looking like. And then you have to go and agree on the various transport encapsulations that you're going to go run. So you can put the information, if you're running v6, you can put it into an extension header. If you're running VSLAN GPE, you can put it into a protocol extension header. If you're running SRv6, there is TLVs in the SRv6 header right now. NSH has type 2 metadata defined already. Also, what it comes down to is for some subsets, NSH has that already with tracing. For proof of transit, for instance, of verifying the path. You don't have that, you can use yet another NSH type 2 TLV. So you can think of those things, and we have to go and look into the various transport encapsulations one by one as we define them. And well, from a concept perspective, that's fairly simple. So we define a set of data formats that we want to go and carry across. And some of these data will be kind of static throughout, or no, the amount of information that we carry across a particular domain is static throughout the entire domain. In other cases, well, we gather information as we evolve through the path. So if you look at that particular example, unfortunately, the numbers in the little circles don't render, so the PDFing lost us some information. But at the first node, we would take the vanilla payload that we're getting, the vanilla packet between header and then payload. We're inserting some information. We're inserting a fixed array. And that fixed array has information that is kind of either per hop or end-to-end. And we keep in that packet size constant. So it's a little bit like tunneling, but it's not really a tunnel header. The header sits somewhere in the packet. But we're not growing the packet dynamically like what, say, originally other approaches have done, especially route recording, right? So you all remember 791. And then incrementally, we're adding that information as the packet traverses through the network. And at the very end, you can export that thing. And I think having IPFix I heard mentioning earlier on, I think IPFix as a container format would be a very viable format to export that information. But you can also split the thing directly out into something like Kafka. What we do today on a prototype implementation that we have on FIDO, we export using IPFix. So what information do we need to go carry? I mentioned that already. So there are certain things that happen on a per node basis. So we need to go and define the data formats for that. Node ID, ingress interface, timestamp, generic metadata. There's certain things that happen only at specific hops. If you want to verify that a packet's happened to visit certain hops, doing proof of transit, well, this is only happening at those specific hops, not at all hops. And then things that are only kind of edge to edge or end to end, which is sequence numbering. Understand whether a packet got dropped in transit, right? So all of that needs a home, and you can define data formats for that. And that's what we've done. That's what the one draft is about. So you'll find things that happen on a hop-by-hop basis, which is basically tracing, and then you put in an array at the ingress node, you strip the array at the egress node, and what goes into the array depends on what information you're interested in carrying. So kind of if you go crazy and want to go to record everything, you would maybe record like node ID, ingress interface, egress interface, timestamp, and additional metadata like GPS geolocation. We have even a hop limit in there, which allows us to compare the TTL of the packet or the hop limit of the packet to what is recorded there. So we are able to understand whether we miss out individual nodes in between, so that you have some information on whether it really updated, whether every single node updated the packet or not. You also have some information on whether you filled up the array and, well, you ran out of space in the additional header that you put on. Proof of transit, we'll briefly touch on that in a minute. It's basically to record or to carry two pieces of metadata that allow us to understand whether all nodes that are supposed to be visited by the packet are visited, and we can do that then and verify in a cryptographically secure way. Edge to edge, you add sequence numbers to the packet if you need to. So if you run a protocol that doesn't carry sequence numbers so that you are unable to detect packet losses or reordering. And then it comes to transport. And what we put out for now is mostly informational draft that shows examples on how these end-caps will go. Depending on how the overall discussion goes, we obviously will come up with individual drafts that will then be standards track to ask for individual code points for TLVs, depending on the transport that we are going to go embed the metadata into. I promised one word on proof of transit. It's trying to solve the question that I think is around for quite some time, and it was brought up by one of the co-authors, Steve Ewell, those days working for Goldman Sachs, these days working for JPMC, so in the financial industry, that said, well, we have a feed from many of our financial peers, and how do we make sure that all this traffic actually makes it through the sequence of firewalls that we've seen? Today, we can look at the cabling, put probes into the cables, and make sure that every single packet is traversing. But if you move to the virtual world, how do you prove that? Single vSwitch configuration, everything goes nuts. So we want to verify every single packet. Can we kind of verify or put a verifier into the packet that it really has traversed every single firewall that we wanted to traverse? So that's the question that he wanted to solve, and we started to solve it. So what we're doing is we take a secret, we split the secret into as many hops as we want to see verified. We distribute these pieces of the secrets to the individual hops that we want to see verified. And as packets traverse through the network, they pick up the pieces and then are able to either reassemble the secret or not. If they're not, well, something wrong happened. If they're able to reassemble the secret, then fine. So there's multiple concepts on how you can skin that cat. You can cryptographically, so you can kind of incrementally encrypt the packet, and that way, then at the very end, compare to what it should have been from a kind of encryption perspective or what you received. That's quite expensive. So what we ended up doing is a very, very lightweight approach, which is based on Shamir secret sharing. Shamir secret sharing uses a polynomial as the secret, and it goes all the way back to school math. In school math, we learned that a polynomial of degree n is defined uniquely identified by n+1 points. So if the polynomial is a secret, we can use individual points on the polynomial as shares of that secret. So for instance, if we have a polynomial if we have a service chain or a path with 3 hops that we want to verify, we take a polynomial of degree 2, we take 3 points on that polynomial, and we dedicate to every single hop 1 particular point, and then, well, the traffic, the packet will pick up all these individual points as it progresses through the network, and that at the very end, you can do Lagrange interpolation and retrieve the polynomial. The beauty of this overall concept, it sounds overly complex, but what it boils down to, and if you read the draft, it boils down to 3 additions, 1 multiplication, and a modular prime operation. So it can be done really, really cheaply, operationally wise. And we've proven doing that in a prototype implementation in VPP, so FIDO. So that's open source. And, well, you need a controller to go and create the secrets, split the secrets, distribute the secrets, and that code resides or is starting to reside in Open Daylight. There's patches for that out. Hopefully we'll get that into Boron release. That's pretty much it. So there is running code, and there's also a couple of demo videos that we put out on a YouTube channel. The key question is, and that's my question to you guys, is where does this thing belong? Does it belong into routing, or does it belong into ops? And I want to hear opinions about that. And well, Benoit for sure has an opinion. Maybe other people have an opinion as well. Thank you.
Hi, Dan Bogdanovic. Nice work. The one thing on the being able to verify that the service was correctly provisioned is a very important one, especially in the overlay situations. And it's not just from debugging perspective; it's also from the service assurance perspective.
Correct.
So even when so that this gives a tool to the operators that they can essentially, provide the SLAs for the virtual services that they're creating. I would keep it in the ops area instead of the routing area, because it's more about what information what metadata will you collect from that, and this is more operational data than what it has to do with the routing.
Thank you, and I agree. So the key starting point for us was indeed overlays. So we want to do SLA checking on overlays at all levels, and well, which is also why we have an implementation of the virtual forwarder as opposed to we started the battle with the A6 day one, right? Yeah. We can do that day two.
Yeah, and I have an implementation. I also have a Young model, already developed.
Cool. Let's compare notes.
Yeah. Bert Wijnen, you asked the question, but I would like to ask a question first. And it's so I like the idea. Did I understand correctly that you put that extra data in every IP packet that you send around?
That's up to you. So obviously you can classify the traffic first and then say, okay, for this particular type of traffic, I want to go and see metadata being added. And even more so, if you have a implementation in place that naturally classifies traffic like segment routing or NSH, then you obviously piggyback on the existing classification mechanism and you say, for this particular service chain, I want proof of transit verification to happen, and for another one, I don't.
Okay,
so it's not
good.
necessarily all, but you could do it for all.
Yeah, and so potentially people might do it for a lot of packets, and so that's fine because I see added value to this. But you made one claim like there's no extra network traffic, there's maybe no extra network IP packets, but there is certainly extra traffic.
Correct.
And if you do a ping every 5 minutes, I doubt that that's more traffic than what you're adding here. But that's just
absolutely.
one claim.
I think
that
you're
you
absolutely right, which is why I tried I got some kind of grief yesterday. Some people said, well,
no,
this is not really either
don't
active nor passive, which is why I call it in-band.
Don't worry too much. I'm just making sure that I understand.
There is something extra. Yeah, it's not. There's no free lunch, right? So if you want data, you got to create data.
And I also have a quick question. I stuck myself in the queue. What happens when you add stuff? And I mean, it looks like you're going to run into MTU issues in many cases.
So good point. We are trying to constrain, we are constraining implementation today to a single domain where we are in control. And that means I need to make sure that the extra information that I piggyback on top of the thing fits my MTU size of that particular domain. If not, yeah, well, you have a problem. Okay. But that's how we kind of frame that problem. So it's like, be clueful as an operator.
So just to respond to Bert, the point is that our existing troubleshooting tools are not designed for any virtual services that we are creating. So sending any of these, how you could then if you really want to create and test a service, you have to create a very specific path, and the ping will not cut it there because you will not know if it goes on that overlap.
So let me be clear. I am not, Bert Wijnen speaking again, I'm not against this concept and this, I tried that, but Benoit did that, yeah. That guy over there. Anyway, Bert Wijnen. So I'm not against, and I see a lot of value in this, but I just wanted to make sure that we, don't attribute too much value to the fact that it would be less traffic, because it's adding traffic.
It's on the real traffic as opposed to you sending fake traffic that you can easily then kind of prioritize, handle specifically. I think that's the key point.
Hi, Chris Morrow, Google. So we have I'm sure everyone has similar issues, right? It'd be nice to solve some of these problems. I'm a little wary of anything that steals CPU cycles off the router, especially interface cycles, right? It's expensive at 100 gig to do this. So unless the hardware that's in the box is prepared to do it.
It's
good.
So from a VPP perspective, we're about to publish results. We've done tests on vanilla iOS routers, and the increment that this takes is in the area of 1%.
Vanilla iOS, like 100 gig capable box? No.
So vanilla iOS software forwarding, so ISR style routers, so the small ones.
Okay,
all
so
the big ones on VPP. Well, we're gonna go get you that data, but the overall added overhead is relatively small.
Relatively small.
We'll get,
I'm sure there's someone who could tell me how many
many
microseconds a packet can live in a box at 100 gig. I get it.
We'll get data.
You're getting it better in data. That's fine. I'm just saying, wow, this could be super dangerous to packet forwarding rates, which are important to me.
We'll get you hard data next time. I promise.
Yes. Italo Busi. Two comments. One comment, I think in-band OIM and out-of-band OIM, we have a lot of definitions defined in the past, and this is a little bit more than what we call in-band OIM. So maybe we can call it per packet, packet header OIM, something like that.
If you have a better terminology,
I will.
Please come and see me.
Yes.
This terminology thing already drives me nuts.
I can understand.
And I don't have a nice term for it. So
I understand.
if you have a better one, come and see me.
Let's talk about that. Yes, just that in-band is confusing because we have already a lot of in-bands
but
OIM.
active and passive is equally confusing.
Yeah, I agree.
Whatever, right? So,
Yes.
And I don't want hybrid, please. Right?
Yeah. Yeah. The second comment is this. I understand this solution is changing a bit the way the intermediate nodes forward packets. And especially if you go with MPLS, because I had experience in the past with MPLS TPOIM, we need to talk at, I don't know where to do, ops area or routing area, but at least we need to talk with MPLS working group and everybody who works on the data plane, because we are making a change to the packet format and to the forwarding plane, just to make sure that everybody is in line with that.
Okay.
Yes. Hi, Dan Bogdanovic. So we did testing on an NPU on the Broadcom. And they were, we were doing the test, when we were launching the test, it was purely event-based driven. So it wasn't, any periodic one. It was looking for event, either creation of a service, then to do the assurance, or when, some of the predetermined SLA data was falling, below the level, and then we, ran it. And the overhead was, less than 0.1%.
Thank you.
And this was done on Trident 2. We didn't do any Tomahawk testing.
Okay. Any other comments?
Couldn't get Benoit to say anything, but that's all right. Thank you.
And let's keep them both short.
Hi, Al Morton. I'm always short.
Yeah.
Frank, this thing really is hybrid in terms of classification.
Yeah.
So
but hybrid doesn't mean anything. So that's
well, in the context of active and passive,
yes.
active and passive are the extremes.
Correct.
And many new techniques are being developed in between that have attributes of both. So this is the one where it's dependent on the stream characteristics of the user traffic, which is like the observational passive, but you're adding information that's dedicated to measurement. So that puts it in the middle. And yes, this is an informational RFC that provides these definitions, but we can't put definition drafts on the standards track. There's no way to evaluate their implementation.
I just
later.
want something that is kind of, rather than, as you say, hybrid is anywhere here. Where is hybrid in the middle, right? Somewhere in the middle.
Well,
and that's too vague. And I wanted to have some terminology that refers to that particular principle that uniquely identifies it, and I haven't found one yet.
And by the way, we have classifications of hybrid. So there's a type 1, a type 2, and something else that we named. And so if you read the draft, I think you'll find that it's a little closer to not just plain hybrid. I think. Please, let's try to live with it. In fact, definitions are important in standards work. This is where
if you can help me find a proper term, I'm all for that.
All right, cool. And incidentally, I like this, and we've already got a draft moving to IESG based on IPv6 extension headers. Does something similar. So I think this is, people are beginning to see this as a valuable tool. Thanks.
Cool. Thank you.
So Benoit Clay speaking, since you wanted to hear my feedback. So there is a distinction between, is there interest to work on something which is more important to me of where it is. If there is interest, and I would like you to get the sense of the room, then personally, I agree with what Diane mentioned, that the ops part of this is more important for the operator than the routing part in terms of where.
Okay.
So actually, feel free to ask the question. You can do that.
Okay. So exactly the question you asked before. So is there, I want to ask two questions. Is there interest, first question, is there interest to work on this topic? Like, no. Okay. Then do you believe we should not be working on that topic? No. Okay. Then this was for me the primary question.
Okay.
Now my personal feedback is it should be in ops. I would prefer ops.
I'll let you do the
and just as a clarification, in ops, not in opsawg.
That's the thing, because then we've got like questions how it relate to Lime, for example, anything like that. So, and I'm not sure yet about that, so I haven't read the full.
Me neither. So, all right. Okay. Thank you, guys.
Great. Thank you very much. And that wraps up the opsawg section. Ops area folk nicely let us use a little bit of their time, and so we've eaten into their time some, but not too badly. So I think that we are going back to this set of slides, and welcome to Ops area. Do you want me to stay here and run the slides? Do you want to plug yourself in? Okay, I'll stay here and run slides.
Yep.
So welcome to the ops area side of the joint Opsawg ops area meeting. We're your friendly neighborhood area directors. Benoit Clay is to my left, your right, and Joel Yeagley. So our agenda is relatively thin this time. We have a discussion of a BOF that we're interested in, and then a section for me to pontificate on where I see operations specific non-management work going, and how the division of labor on that is going to work in the next year or two. And then we have the open mic section where Warren will do an interpretive dance, or we will take comments from the active participants. I won't call you the audience. You might be hostages, however. Next. Are we switching to, oh, yes. So this one doesn't have a slide. So one of the opportunities we have in organizing BOFs is to see if we have critical mass around work in the IETF. There's two BOFs, I think, that point to interesting directions that work in the IETF is going right now. One of those is Quick, which I believe is coming up today and tomorrow morning, and then Plus. So these are both in the transport area, and you could ask, what does the transport area have to do with ops? And if you were asking that about SCTP or DCCP, I would probably be aligned with you. But transport is actually undergoing something of a renaissance because they seem to have decided that new transport layers are probably not going to happen. And so if you need to make hay, you need to make it with UDP because your options are TCP, ICMP, and UDP. And if you're tunneling over ICMP, you're probably a jackass. So these two BOFs are aimed at adding the sorts of flow control semantics that we expect from TCP to either a generic encapsulation or that runs over UDP, which is plus, or to a substitute for TCP, which is quick. So these have interesting implications for operations work because we're used to, for example, on the IP fixed side, we're used to looking for L4 headers, not L4.5 or 5 or L4 number 2 headers. And also on the middle box side, things like firewalls also have a tendency to, or really any mediation device, including switches and routers, have a tendency to look at those L4 headers. But if the connection semantics and in fact the behavior of the protocol are now upper layer phenomenon, you're going to have to reach more deeply into the packet in order to do things like policy enforcement or protocol inspection and so on. That has the potential to sort of remake a number of things that we work on, and in particular, if you were concerned about pervasive monitoring, and you were also concerned about the ability to manage your network, the opacity of upper layer values may either be a problem for you or an opportunity. So I think there is abundant opportunity for this work to have impact in various operations and management areas, and we should look at it carefully, provide useful feedback, and draw our own conclusions as to whether it's worthwhile or not. So I will certainly be looking for input from the community on these things as we look beyond a BOF at working group formation. And I think both of these efforts, look pretty solid, which means that we could have to live with them for quite some time. They also look like they have the property that they will either be successful or they will be failures. There's no opportunities for niches here. So a repeat of SCTP or some other transport that we've worked on in the past, which has run aground on reality, doesn't seem like a likely outcome. These will either succeed or fail. So that's
Joel. It's Dan York. I would also just encourage operators to pay special attention to Quick, because the reality is this is not something theoretical. This is actually being deployed and used, has been in Chromium since 2012. Google's using it for a lot of their sites and the pieces that are there. So this is the case where it's not something that you will or that you may see in operations. You will. It's there now.
Yeah, it has. I mean, it has demonstrated utility, right? And it's sufficiently widely deployed at this point that we're beginning to have to grapple with its behavior already. And I think both of these things point to an important opportunity, which is that the IETF has historically done an extremely bad job at imparting connection-oriented semantics to UDP applications. We've sort of left that to the developers, which means middle boxes kind of have to make their own decisions about this. And these two efforts sort of spell that out in extremely clear ways. So we are in fact treating implementers who have to do policy enforcement on these sorts of things much better with these tools, and other considerations. So things like load balancing, for example, what is a flow can be a hard thing to determine. How long you should keep a session state around for the occasion where you might actually receive one more packet associated with the UDP flow is an interesting problem space. So Elliot.
Hi, Joel. It's Elliot Lear again. Yes, to everything you just said and more. So in working in the IoT space and with MUD in particular, I just want to bear the relationship out here a little bit as to why this comes up. That worm that I showed on the screen, right? That indicates lateral exchanges that infect other devices. One of the things that's important to us is directionality, understanding who started it, right? And who's supposed to be talking, right?
Yep.
And the other aspect is very much, and when has the communication ended? Because they go hand in glove, right? And so the more explicit that is as to who started it and when does it end, I realize people get into privacy discussions about what information is leaked over all this stuff, but from if you think about it in the context of, say, a nuclear reactor that, or a facility that uses these actuators, this is the stuff that gets used. So it's really important to pay close attention to this.
Yeah, I mean, directionality is super valuable to me. I mean, as a CDN, to the extent that I do policy enforcement, it's all stateless. But it's super convenient to not actually receive SINs on some ports because I don't want to listen to those. And so when you think about it deeply, it's relatively straightforward to use stateless ACLs to knock down stateful protocols in one direction, but without doing damage in the other. And those are things that we do, and this has an opportunity to either make that harder or easier. So we look forward to that. Next slide, Dick. No, I think that included most of my thoughts on Plus. Yeah. So I've been at this 3 years, and this ultimately will be my fourth and final in this particular role. So I thought I would reflect a little bit on what's happened and where I think we're going. It sometimes feels like operations is perpetual, that we don't get much done, but we do meet a lot. And in some cases that might be true. But I think what I have seen in 3 years is evidence of significant productivity. We've closed off some important lines of work because they are completed and not because we got tired of them. We have closed off some working groups because they were not meeting our objectives. So I think that's solid and important and healthy from a measurement approach. We've also created new activities where we've seen growth. And it's tempting to see this as sort of siloed. So, operations does its thing, management does its thing, the internet area does its thing, and occasionally they throw things over the wall at us and we pick up the scraps. But work does evolve, things do get deployed, and so when we look at where we are today, you can sort of break things down into like some pretty broad categories based on how we divide up the labor. So not all of the ops area working groups are actually run by ops ADs. And that was part of a transformational effort in the ISG. We've done a couple of different attempts at transformation. One is moving around the roles, but the other is shuffling the working groups. So putting working groups in the areas where the expertise is, or with ADs who have particular sets of experience, and also prioritizing particular work within the IETF so that it gets the attention that it needs. And so that transformation actually involved, for example, me taking on more working groups and Benoit taking on all of the Yang work in the IETF from an oversight role, if not necessarily from an ownership of all the working groups where it's occurring, because then he'd have like 40 or 50, which I think is possibly unsustainable. So reorganizing around changing demands. In the future, you can imagine new operations working groups, including those being chartered with a non-ops AD sponsor. And so I think particularly in the security area and in the maintenance of security protocols, that's likely to be a thing that happens. Existing working groups may shuffle into ops, or we may continue the historic trend of things that with titles like ops or deployment, where we reconstitute things when we complete major milestones. So CIDR is one that is being discussed now because it is approaching completion of its major documents, and yet, you know, I think the effort around CIDR is far from done. I certainly wouldn't consider it deployed to a level that I would consider commercially useful for myself, right? As an operator, I think a great deal of experience needs to be developed around it. And when I see drafts covering things like misconceptions on what a ROA actually is circulating, I think that our work in that area is far from complete. So I see opportunities in other places like that. The other thing is operations is going to be different. The consumers and participants in our work are not preoccupied with the problems that we addressed in operations working groups in the past. You know, it's my opinion that I don't think V6 transition technologies have a bright future. I prefer to think of that in the context of V6 operation. And I think the growth that we see in commercial activity with V6, in network deployments, that we've already crossed the tipping point, where if you're serious about this, you're deploying the network and not trying to plug holes in your legacy technologies. Speaking of that, we have now 2 decades worth of operation and management for TDM network technologies that we no longer care about. So ATM, Sonnet, ADSL, whole bunch of stuff that we're not going to work on so much anymore, because you know, from where I sit, I only have one kind of link layer, and that's Ethernet. And so the challenges that I have running over IP over that are mostly straightforward, and where much of the work is going. Now, that may come along again in the form of IoT stuff with its own unique link layer requirements. and you can see work on automobile networks already sticking its nose under the door in that respect. But there's a lot of things that we have spent a lot of time on as a result that we're not going to think about very much in the future. Network operators like myself are no longer box jockeys. That is kind of like the old economy form of operating a network. We orchestrate complex systems, and so that that applies if you are running an IP network. That applies if you are an application service provider, and it certainly applies to data center operators and the various combinations of those things. So that means in many respects, operations is going to have to pop up a layer in the stack, much like management has. And we will see the Yang work infect actual operational networks as opposed to just infecting the mind share of vendors. So that is going to be a challenge that we're going to have to rise to meet. And I think one of the components that we see in that is the enormous pressure that the software tooling is exposed to in Yang. Our networks and their demands, in some respects, as we build these and as we add orchestration layers to them and evolve them, are running faster than customer evolution does. So something that takes a year to do in the IETF is maybe not, it wasn't interesting to operators before, and it definitely won't be at this point. So that becomes a challenge to us to be timely. I think some of the work that's being done on catalogs is one example of this, but there are other forms of sort of rapid proprietary evolution versus enterprise developers, people like very large network operators that begin with a G. For example, throwing their technologies over the wall and either expecting people to adopt them quickly or realizing that people are adopting them quickly and that that there needs to be supporting work before that spirals out of control. And finally, I'd say that some working groups that I took over when I started were relatively nascent and in fact have massively increased their level of activity. DNS op may be a sufficiently high volume now that it's a DOS on the process of actually getting things through last call, because I prefer not to have multiple documents that we're discussing, in the IETF last call at the same time. But they're at significantly higher levels of activity right now. OPSEC is at a lower level of activity, and these things seem to be normal, so we need to manage that over time. And certain activities in other areas, like CIDR, but also in the netcom space, are entering maturity phases where their level of activity may drop, but the actual interest on the part of operators, because they have finally gelled to a point of stability, is going to increase. And so we have to contend with how to address that. So that's what I wanted to say. And I think we can go from there to open mic.
Dan York, Joel, thank you for your thoughts on that. I would just say I find it, I'm glad to hear there's some things like CIDR ops, for instance, being considered, because as somebody working more on the deployment side of trying to get these protocols out there in wider usage. It has been a bit of a frustration at times in the past when a working group has done its work, delivered the protocol, and then we get it out there and start to get it used and find that there's challenges with the protocol and needs to be brought back in, and sometimes it's not always been clear where to bring it. So I'm glad there's some thought to that that's happening in that space.
Thank you.
Yes, hi, Dan Bogdanovic. I would try to reflect on the Yang modeling parts, because we should really rethink for some of the modeling efforts if we can find another process or just make the IETF draft to RFC process somewhat flexible. We are stuck with this where the vendors are not looking to implement a model until it's becoming an RFC. And people are asking, so we would like to hear more about implementations. And it's not easy to do through various model iterations where you're learning from the experience. And I'm speaking of previously when I was working for a big vendor, and they were saying, until it's an RFC, we have no desire to implement it.
Yeah, and I think there's another component to that, which is other SDOs are dependent on us, either are looking to us or have work that intersects with ours that requires coordination. And so to the extent that that process is retarded by the amount of time it takes to push something through, we're seriously challenged. I mean, I think when we started the effort at focusing on the Yang work, we figured that we had about 2 years to do this right, or screw it up, but that it would be a concerted effort and that would require a significant amount of energy to achieve, and that it might necessarily be transformative of the way that we process certain kinds of documents, or even whether we process them at all, right? I mean, because that is actually possibly one of the answers to this, is that there are certain things that, due to lack of stability, can't actually leverage the IETF process effectively, which is not a good thing to hear if you're a large vendor, because lack of stability means moving target, and that's, you're back in SNMP V1, V2 era, where you're chasing enterprise MIBs or endless variations of these things, and that's not desirable either.
So let me say a few things. First of all, you were a NetMod, right? Right, but in my intro in NetMod, I made pretty strong statements that if we don't produce those Yang modules as RFC ID within a year, we should stop doing those in the IETF. This is exactly in line with what Joel mentioned, that the operator is not interested in something that takes more than a year in the IETF. Now, something important, we saw that coming for a long time. We've been creating the tools, for example, in the hackathon, to look at the number of Yang modules, a tool to see the dependencies. So we've got more than 200 in the IETF, but okay, the IETF is just one thing for me, because I care more about what the industry is moving. When I collect all of these, this dependency graph is like ugly. I've got 1,000 Yang models. I've got, the last time was yesterday, discussing with different SDO here on how we're going to work on Yang models together. So now the thing is that we have roots of Yang models that are key. Routing, interfaces, thing like that. What would be, in my mind, an issue is that if we would have multiple sources, so if I take this big dependency graph, if we could target those couple of very important Yang models to make them right, then we would have the right be able to extend this. Now, coming back to your more flexible versioning, that's also what I mentioned in NetMod yesterday, that the next thing we will need to solve. Now, I still make a priority to standardize those very important Yang models first, because without the RFC ID for some of these, we're going nowhere, right? And then the versioning, I agree, it will be the biggest issue. And this is why we've been working on the catalog in the hackathon last time and again this time. And that will be a key aspect of this versioning. And coming back to the point that Joel made, if it takes a year for an operator to try to get something done in the IETF, maybe it will not be where the operators will be.
Well, I can just say from personal experience, it's now 2 years. And I have a draft what has been going for the past year through last, call work, for the working group last calls. And there is always, oh, we don't like this, we don't like that, we don't support this, we don't support that. And look, this is just a process that, where we are at, but just having, updated process or creating some flexibility that some of the vendors who would be inclined to do it and saying, well, so this is like an interim RFC or a temporary RFC or something like that that says majority of the working group is agreed on that or something like that would be helpful, because as my previous employer, they had this sort of, well, if it's really not what we need, we will not support it until there's an RFC and until the customers are asking for it.
I agree with you. We'll have to solve this import by revision in a better way. Yeah, I hear you. Now, also one more thing. I think it's a kind of dream to believe we're going to have the Yang doctors, the Yang modules right first time.
Bertwijnen, so I remember from the time when I was area director, there were, I forget whether it was MEF or some other SDO, there was actually defining implementation agreements, and they often were based on internet drafts that we had, so they were not stable, but they took like, some snapshot of internet drafts that were running, and they were doing a definition of implementation agreements, and they would say, okay, we all base our current implementation on this internet draft. So that, I'm not sure that's a really, really good idea, but it certainly would give you some flexibility and might help, to motivate vendors to actually implement stuff, right?
Yeah. Yeah, I mean, I think one of the things that's happened is we've gotten much more comfortable with the idea of versioning. And so people are actually willing to target things in GitHub, which is sort of the either, I mean, okay, so it's the canonical example of something being unstable is where anyone and everyone can contribute to it. On the other hand, like the point in time at which you're referencing is stable once it's created. So we are in a much better position than when we were tossing Word documents or NROF at each other over email, right? With respect to versioning, like we can be relatively transparent with respect to agreement on which document we're discussing now, which was historically quite a large challenge for us. And yeah.
And one more thing, what Bert described is exactly GitHub. Now, if you connect GitHub with the service catalog and that you see that version 10 of that document, and I mentioned document, not draft or RFC or a document, is implemented by 5 different vendors, then maybe you've got the answer on what to focus on. So I believe we'll need a model like this pretty soon.
But unless you can point something to the executives who are approving that work, you're dead in the water because you're relying on the enthusiasm.
I don't think this is the issue. I mean, whenever you've got customers telling you as a vendor, no, wait. Whenever you get customer telling you as a vendor, I want to have that Yang module implemented in GitHub and that version, and I'm paying, I mean, the VP will change the direction directly.
Yeah.
So in the end, it's about the operator asking what they want. Some of them, and there are two schools there, some of them want to have like the RFC number. Some of them want to have something which is more flexible in terms of that version in GitHub.
But we're also, I mean, I think one of the important points here is we're actually arriving at the point where the consumers of this technology are arriving at the level of maturity that they can actually, instead of telling you what they want, they can tell you what they're implementing and deploying, which is a way different scenario than it was a year ago or 2 years ago. Because I mean, I've blown smoke up the butts of my vendors. I'm sure I've demanded things that that I'd never actually used. Yeah, and I might have even paid for them and not used them, which is like, yeah. I mean, right. Everyone like, well, I mean, no one really wins in that scenario, but like, I mean, I think as this stuff was a sort of an informative stage, like that's a thing that happens, right? Like you're like, oh yeah, we could do it this way, but that stuff doesn't gel until people start implementing it, and then the demands actually crystallize, and when they crystallize, then we can do operations on them, right? Before that, that's, you know, when it's uncooked, like it's you know, it's still waiting to be molded and produced, and that's a challenging time for implementers. But yeah. So, but I think I mean, I look at what's happened like in the last 2-3 years, and I see like a much more mature space. So I think we have an opportunity to capitalize on that. But as you say, we still have some serious challenges with actually producing the product here. So with that, I think we're actually done. Any other business at the mics? Okay, well then we will declare victory, and you can have your time back. Thank you.
Oh, blue sheets. If you haven't signed them, please come sign them.
Just need a pen.
Nice to meet you.
About the
Yes. Right. So can you please? I want to present someone. Yes. Okay. Right. Yeah. I'm going to anyway. Yes. So you were. I was fully paying attention with what. But we talked about this. Yes. Let's get down the door now. I'm making another today. Okay.